Okay. Hi friends. Okay, in this particular video, I'm giving you a brief idea about what are the softwares which are required to write assembly language program of 8086. Okay, and where those softwares are available and how to install those softwares. And later, after installing, how to write the program in those particular softwares. I will explain briefly. Okay, let us see. See, there is a one website link called as see here, wintechworld.blogspot.com, wintechworld.blogspot.com, wintechworld.blogspot.com. You just select this link. In comment section also I will indicate this link. Okay, so if you select this link, see here, so bottom there is a one tab. Download MASM for Windows 32-bit, similarly 64-bit, Win 7, Win 8, or Windows 10, and even Ubuntu related OS also. Simply press this one. We get softwares. Here one is DOSBox is essential for writing program. So simply select download. We get a DOSBox application. And one more file 8086 assembler.zip. It's a zip file is also required. So these two are required. Simply if you download, okay, then what happens here? So now I was selected DOSBox and I was downloaded 8086 assembler also. So if you install the DOSBox, we get this type of shortcut. Okay, and in the 8086 assembler also, just you extract it, we get this type of folder. Okay. After extracting, we get 8086 assembler. In that there is a one folder called as 8086. This is required. So here inside of 8086, let us see. See, there are some applications. One is called it as a debug, edit, link, MASM, TASM. Okay, all are essential. So simply you take this 8086, copy only this folder. Don't take 8086 assembler completely. Take only 8086 folder. Copy it into any of the drive except C drive, maybe D drive or E drive. You copy this folder in that particular drive. So I was already copied this 8086 folder into D drive. Later, let us see how to write the program. Okay. So now first step is for writing program after installing DOSBox. Simply double click DOSBox. Let us see what happens. So we get one command window like this. Here you mention mount space where your 8086 folder is there. You select that particular drive for that. So in my computer 8086 folder is available in D drive. That's why mount space. I am selecting D drive. Mount space D :/. Then we are in Z again. It will checking whether the local directory is present or not. Then later D:. For selecting D drive, D:. So now we are in D drive. So then in order to select 8086 in D drive, you type CD space 8086 folder name. CD space 8086. Then we are in 8086 folder now. Then in order to write program, we should type edit. For writing fresh program, edit. Then enter. We get untitled screen like this. In order to maximize it, Alt plus enter for full screen or maximum screen. Okay, this is the screen where we can write program. So first step for writing any assembly language program is we need segment registers. Generally for writing program we need code segment registers. So first we should write code space segment. Code segment register is essential. Then later there is a one assembler directive called as assume space C::code. So I already explained what is the role of assume directive. So assume directive is a one assembler directive, and this assume directive will assign 16-bit logical address into 20-bit physical address automatically. Okay, this is essential because 8086 contains 20 address lines, so we need 20-bit logical address. This assume directive automatically initialize 16-bit logical segment into 20-bit physical segment automatically. So these two are essential. Like C program, how headers are present, here also these two lines are essential. If your data segment is present above code segment, data segment is also required. But most of the programming, code segment is enough. Then later start. It's like a C program, we are indicating like a open brace and then later closed brace. Like that, here start. Start indicates start of the program. So for every program, these three steps are very, very important before writing the program. Then next two lines comes like a body of the program. And one more point is these three instructions are assembler directive instructions, and these three instructions may not generate any machine code. Okay, but coming instructions are processor control instructions, and these instructions will generate machine code. Let us see first one, exclusive OR AX comma AX. So why I am writing exclusive OR operation? I already mentioned exclusive OR means when two inputs are of opposite type, then only output is 1. Here my source operand and destination operand both are same registers. If you perform same registers exclusive OR operation, then my destination becomes cleared. So my AX is cleared. So AX is a 16-bit register. So in that AX register, all 16 bits are cleared. Then what is the next step? Exclusive OR over. Then other register, for example, my aim is I need to add two 8-bit numbers, just for seeing the results and all. So for that I need BL register also. For that reason I am clearing BL also, move BL comma AL, because in AX already AL and AH both are cleared. AL is already cleared, so that's why AL data is now moved to BL. BL is also cleared. So preferably for writing any assembly language program, the general purpose registers must be cleared before writing our main program. Okay, now the next step is write our program. For example, my aim is I need to take two numbers, starts from 3000 H location. For that I am using one 16-bit register for selecting 3000 H. Then later I am writing like this, move AL comma box of SI. So this addressing mode is called as register indirect addressing mode. In this addressing mode, what happens? My AL takes an 8-bit data from the memory location 3000 H through SI register indirectly. Okay. So now AL receiving one 8-bit data from 3000 H. Next I need one more 8-bit number from another location. For that I am incrementing SI. Then my SI is now 3000 H becomes 3001. Then move BL box of SI. So my BL takes data from 3001 location. Okay, then AL is receiving data from 3000 and BL receiving data from 3001. Then add space AL comma BL. Then what happens? BL data is now added with AL data and result is stored in AL. So result is available. Where I need to send result into next location. For that again I am incrementing SI. Now I am writing like this. Move. I need to send AL result. After adding 2 bits, we get two 8-bit numbers. We get result in AL. This result will move to next location. For that move box of SI comma AL. If I write like this, what happens? AL already having result. That result is now moved to next location. Nothing but 3000 for first number, 3001 for second number. Then after adding we get result. That result is stored in 3002. So 3002 now contains result. So now our program is over. Then for writing for mentioning end of the program, always we should write int3. Int3 is one interrupt type instruction, and this instruction is used to end the program, end the main processor program. If write any instruction after int3, it won't execute. So body of the program always end with int3. Later what happens? So we should close the segments. Already we open code segment and we open start. So these two must close here. For that code ends, then end start. We should mention here. Code ends, end start. That's all. Then programming is over. So these two steps are also essential. Okay, at the end of every program, so at the end of the body of the program, we should close. We should write like code ends, end start, because already code ends, code segment opened. Now here it is closed. Start is here, started here, then end here. Okay, so these lines here, these lines are called as body of the program. Only these instructions will generate equivalent machine code, but remaining instructions, first 3 and last 2, those are called as assembler directives, and these instructions may not generate any machine code. So programming is over for adding two 8-bit numbers, starts from 3000. Then what is the next step? We should save. For that file, select file, then save. So remember here one point. Okay, for performing any program, the file name should be .asm. For example, here my file name is 8bit1.asm. So 8-bit addition of first experiment. For that reason I am writing 8bit1 dot. The file extension name should be .asm. What is ASM? Assembly program in MASM. That's why .asm is essential. Then OK. Then let us see folder now D in that 8086 in that 8bit1.asm. File name is 8bit1. Extension should be .asm. So program is over, saving is over. Then what is the next step? We should run. For that let us see commands file, then exit. Okay. So now later. First command is MASM, MASM, MASM space file name. What is file name? 8bit1, 8bit1.asm. This is my file name. .asm first time, MASM space our file name .asm, and press 4 times enter, 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 enter. So here above the is colon 8086, there should be a 0 warning errors and 0 severe errors. It indicates we don't have any errors. Then later we should run link file. For that the command is link link. First one is mason file name.asm. Second time link space file name. File name is 8bit1.obj. Extension is obj. So where we should verify, if you see above the errors, there is an object file name 8bit1 is our file name .obj. So here we should execute .obj file. That's why .obj. Here also 4 times enter 1, 2, 3, 4. Then debug file name. Again file name is 8bit1.exe. One time enter. Let us see, before blinking there is a sleeping line. It indicates that execution is over. Then now we are making our assembly language program into .asm file creation is over, linking is over, .exe file creation is over. Now running. For running, always we should type command is g equal to starting address. Starting address generally for all assembly language programming is 4 zeros here in Mason. That's why g equal to 4 zeros, then enter. So defaultly all registers are having the corresponding values. Okay, now this is over. Then what is next step? We should select two 8-bit numbers, one from 3000, then other from 3001. Then later we'll verify the addition results in 3000. Let us see how to give those values. First step is you select E for giving input E space 3000. E space 3000. Enter. So in 3000 location already B8 is available. If you satisfy, okay. Otherwise, for example, I am selecting my number 05. So I am selecting number is 05. So then if I am writing 05, B8 gone and 05 will be available in 3000 location. Then I need 3001 location also for giving another 8-bit number. In order to select the next location, simply you press tab. So already 3001 location 06 is available. So if you okay, then okay. Otherwise you should change. For example, I am not satisfying with the 06. I am giving 05 here also. So first 8-bit is 05, other 8-bit is also 05. So two numbers we are selecting. Then again run. Then only processor will give you the corresponding result. So after giving the inputs, again run the program. So what is the command for running? G equal to 4 zeros. Enter. Then for seeing the results, the command is where we need to see the results 3000. 3001 for two inputs selection. Result is in 3002. That's why D space 3002 comma 3002. Why I am writing 3002 comma 3002? If I write 3002 comma 3002, only that particular location value only we can see. If you write only D space 3002 in addition to 3002, it will give you the data of other locations also. So we don't want all those. That's why simply we should type D space 3002 comma 3000. Definitely what is the result? 05 is added to 05. Your result should be 0A. In XOR representation 5 plus 5 is 0A. Let us say result is 0A. Like that we can take the softwares and we can write the program and we can execute the program with the help of instructions. Okay, in order to exit from this particular window, so you should write quit, QUIT. Otherwise it won't come out. Okay, no escape button is accepting here, quit. Enter. Then exit. It will come out. Okay. So this is the way of writing assembly language program, and these are the softwares required for writing the assembly language program. Okay. Thank you for